Then let's go back. Then let's look at operating systems and what we can do there. One thing that I think is important to set is the swappiness in the Linux kernel, and we recommend that you set it to 1. Previously, the kind of standard was to set the swappiness to 0, but in more modern Linux kernels, from Linux kernel 3.5, then it is the meaning of the swappiness 0 has changed. So now basically the correct value for the modern Linux kernels are to set swappiness equal 1, and that will reduce how the Linux kernel is going to page out applications basically. Then I think it's also important that you verify if you're using NUMA or not, and this is typically a problem only if you have a multi-socket server or multi-socket servers. What you should do is to run dmessage and then pipe grep -i NUMA, and it will be pretty clear. If it's empty, then you're not using NUMA. If some NUMA stuff comes out, then I recommend that you simply disable the NUMA optimizations, because they do not play so well with the database servers, such as MySQL or even Oracle 11G. They are recommending that you're actually turning off NUMA, because you can have really strange, mysterious lockups otherwise that are quite inexplainable, but has to do with how the CPUs have to move data or access data from a memory bank that is not part of its own core, for example. There are also other possibilities, but as I said, one thing is to set it as a boot option, and then also other possibilities to disable NUMA. Then we would like to give as much disk or as much bandwidth as possible to the disk. We do not want it to write unnecessary. It's enough if it can write out to the database files and the transaction logs in a good, fast pace, and we don't want this to be disturbed. So we recommend really that you mount your partitions with the no A-time option, so you reduce the number of writes on your file system. If you're operating in a virtualized environment, it's really easy to overcommit resources, right? You can create far too many virtual machines on a single host, and that's something that you really have to keep an eye on if that is happening. On the actual host, I think it's good to check, is it swapping? That's really bad for the performance of the VMs. Is it heavily loaded? Is it running hot, high load average, things like this? And one thing you actually can see that on is by looking at the CPU steal on the actual VMs. So if they're reporting a high CPU steal, then that is often an indication that the host is overcommitted. And since it is Galera, it's pretty practical then, because it's really easy to add a new node to the Galera cluster and sync it up, and then remove the node that is part of or running on the overcommitted host. And one thing that I think is really important to keep in mind when it comes to Galera is that the cluster is only as fast as the slowest node. So if someone is running behind, it will affect the entire system. Backups are naturally an important aspect in the day-to-day life, and I think it's key to have a good backup strategy. One could be, for example, to take a backup, every night, or take perhaps a full backup a Sunday night, and then make incremental backups the rest of the week. This is something that Percona Extra Backup supports. With Percona Extra Backup, it is possible then to take the full and incremental backups. But there is another primary database backup option for MySQL, which is called a MySQL dump. I think pretty much everyone is familiar with that. It's also, both my Percona Extra Backup and MySQL dump will give you a consistent online backup for InnoDB tables. But I think that the nice things with Extra Backup is the full and incremental backups, and especially if you have bigger databases, then that can save quite a lot of time to make the incremental backups instead of a full backup every day, as you would have to do with MySQL dump. It always gives you really the full backup. And also with Percona Extra Backup, it's possible to use some more sophisticated compression and parallelism when you're backing up the database, making the backup complete a little bit faster. And also, if you're using the option InnoDB find per table, well, then it's also possible to back up individual databases and tables. But sometimes, of course, MySQL dump is really nice, because it's a quick and dirty way of getting the data out of the cluster if you want to set up a new instance for a developer, for example. But anyways, I would still recommend to use Percona Extra Backup, especially for larger databases. Then, when it comes to Galera and especially recovery, there are a couple of things that I think is important to be aware of. If a node fails, or if you put it into maintenance mode, or whatever might happen, well, this node needs to rejoin the cluster again. It can do it using two different methods when it wants to join the cluster again. It can do what is called an IST, which is an incremental state transfer, or it can do an SST, which is a snapshot state transfer, to join in to the cluster again. And SST, the snapshot state transfer, means that the joining node will ask or will be sent a full copy of the other node's file system, basically, of the other node's MySQL data directory, will be transferred to the joining node. And if you have a huge database, well, transferring this amount of data can take quite some time. In that case, it's quite beneficial to try and optimize the environment to make incremental state transfers as likely as possible. And the incremental state transfer, when a node wants to join, it will basically present itself to the donor, which is one of the nodes in the Galera cluster that is up and running, and it will say that I have applied this much. I have the point when I crashed or stopped or is a particular position, and the donor node will then check if it can actually send those events to the joining node, and it will check if it has these events stored in what is called a Gcache. And the Gcache is a fixed size buffer that's you set up when you start up the node. You decide how big it should be. By default, it's 128 megabyte. And it's a circular buffer. It doesn't grow or shrink, but it's a circular one. So, eventually it will overwrite all data again. And what is storing in this cache is committed write sets that have happened on this node. So when a node wants to join, it will ask the donor then to send the list of, or it will ask first it will try to ask the donor to send the events from a particular point in time when the node failed. And if the donor can do that, and that means that these events must exist in the Gcache. If it can, it will perform an IST. If it can't, it will perform an SST. And transferring 3 terabyte of data is really not so fun, right? So an SST is slow, and that's something we would like to avoid. So the basic thing here that we would like to do is to ensure that we have set the Gcache, to a reasonable size to allow for a maintenance window or for a crash, right? And in this case, I'll give you an example here, and there are a couple of ways how you can reason about this. But here, I'm going to use an assumption here, really, how much data we write to the cluster. And we're assuming that we're writing, for example, 1 megabyte of data per second to the cluster. And then we want to be able to sustain a maintenance window of 6 hours. And so we take down one node, do maintenance for up to 6 hours, and when we start it up again, well, we would like to find that this node can rejoin using an IST. That's just streaming the differences, the deltas that happened during the time the node was in maintenance mode. So the maintenance window in seconds then would be 6 hours times 60 times 60, which is 21,600 seconds. And the rate that we write is then 1 megabyte per second. So in 21,600 seconds, we will use 21 gigabyte of space. And that's exactly how big, well, then the Gcache size needs to be. But I really recommend that you give some headroom, and then, if you can 1.5 exit or 2 exit to have margins, that's great. And also, if you have disk space, I think there's really no reason to be shy with the Gcache size. It doesn't hurt to have a too big Gcache size. It will hurt to have a small one. And then you basically stick in this Gcache size equal 42G into the VSREP provider options, and you have to restart the node, and it will then recreate a Gcache size of the specified size. Gcache file of the specified size. Okay. There is also another way, to deduce the amount of writes that you do to the cluster. And here I was just, assuming that we're writing 1 megabyte per second. But if you really would like to figure it out, how much you're writing, then you can get the write ratio by looking at the sum of VSREP replicated bytes and VSREP received bytes. You sum them up, and then you wait for some period of time and do and sum it up again. And then you take the difference between the two values and then divide by the time between, and you get the rate. And here I'm showing from our status time machine how you can really just go in and look at the VSREP received bytes and replicated bytes, and you have actually there the difference per second, and you have it over a time range. And in this case, we can see that the node is writing 140 kilobytes per second, and or receiving or replicating out 140 kilobytes per second, and that's actually the rate in which the Gcache grows, right? So this is one other way of getting the rate for calculating the size of the Gcache. So then again, it's just to multiply with the amount of time you need to handle for the downtime, basically. And I think 6 or 8 hours is a reasonable amount of to be able to sustain.